This is the first lesson on rational exponents, and let me begin by showing you what a rational exponent is. Here we have the square root of 10, and one of the things that we're going to work on in this lesson is rewriting it in exponential form using an exponent of a half. We'll talk about the definition that will allow us to do this in a moment, but before we do, I want to show you one advantage to rewriting roots in exponential form. Say we wanted to multiply the square root of 2 and the cube root of 2. In the past, we couldn't multiply these because the indexes didn't match. Square root has an index of 2, which we don't see, and of course the cube root has an index of 3. After rewriting in exponential form, and again, don't worry where the 1/2 and the 1/3 came from yet. We'll look at that in a moment. The advantage is, by the exponent properties, if I'm multiplying and the bases are the same, I get to add the exponents. So I can keep the common base of 2 and add 1/2 to 1/3. Of course, I'll need a least common denominator of 6. But 1/2 is the same as 3/6. 1/3 as 2/6, which allows me to add and get an exponent of 5/6. And then I can rewrite this back as the root, the 6th root of 2 to the 5th. And of course, 2 to the 5th can also be written as 32. So I'm not expecting you're following this necessarily. I'm just trying to make a point. If we can rewrite roots in exponential form using rational exponents, then we have available to us all of the exponent rules which we've used before. Now I know that most students aren't especially comfortable with the exponent rules yet, but that's a good reason to be practicing them again. The ones that we'll be using most of the time when we deal with rational exponents will be Rule 1, the product rule, and that says if you're multiplying and the bases match, you can keep the common base and add the exponents. Rule 2, which says if we have the power of a power, we can multiply the exponents. And Rule 4, which says if we're dividing and the bases match, we can subtract the exponents, either to the numerator, m minus n, or to the denominator as n minus m. Either one is fine. And Rule 7, which says if you have a negative exponent, then you can take the reciprocal of the expression in exponential form and change the exponent to its opposite. Keep in mind this really isn't negative or positive, it's just saying opposite. So whatever your sign is in the original, when you take the reciprocal, you'll have the opposite of that sign. We still need a 1 up here, otherwise no one will know that the x with an exponent of m is in the denominator. It's only having a 1 in the numerator that allows us to see that. Here's the definition for rational exponents. There's a couple of very important points here. For instance, you have to make sure that the rational exponent is reduced. It doesn't have any common factors. And n needs to be an integer. That is, this index has to be an integer greater than or equal to 2. But as long as that's true, then you can rewrite from radical form to exponential form. Notice the exponent of the radicand is in the numerator, and the index is in the denominator. For instance, if we have a base of x and an exponent of 3/5, then it'll be the 5th root of x cubed. So if I want to replace the given expression with one written from the other point of view, where all my final exponents need to be positive, then for instance I would write the square root of 10 in exponential form as 10 with an exponent of 1/2. Realize that the 1 is coming from the exponent on the base of 10, which is a 1, but we don't write exponents of 1 usually. And the 2 is coming from the index of 2 with square roots. There is an index of 2, we just don't write it. On the other hand, if I start in exponential form, then I need to write it in radical form. So I would have a base of a, it would have an exponent of 2, that would be my radicand, and then 3 would be my index. So this would be the cube root of a squared. If we have a negative exponent to begin with, then I would use my exponent rules. Since this is a negative 3/5 as an exponent in the denominator, it would be the same as a positive 3/5 exponent in the numerator. And now this would be the 5th root of 5 cubed. If you wanted to write 5 cubed as 125, that would be fine. And for something like this, I would begin in the radicand because that is what the order of operation says to do. If I have an exponent of negative 7 in the denominator, then I can have a base of k with a positive 7 in the numerator. And then to rewrite from radical form to exponential form, I would have k with an exponent of 7/9. Well, that's an introduction to rational exponents. In the next video, we're going to practice doing some rewriting and reducing with rational exponents.